we're traveling from Logan to Boise, and I just proposed a math question to my beautiful wife, Chelsea. And the question, very difficult to calculate, is if you are traveling 80 miles per hour, how long does it take you to go 80 miles? Okay, what do you think, Chel? Let's go through the process. What do you think?
Well, if I run the mile in about 9 minutes.
Wait, what about the tire turning thing you were talking about? Do you think that affects it?
Well, I'm just guesstimating probably about, it turns about 400 times in a mile.
That's just guessing calculations?
Yeah, I don't know how you would work that out.
It'd be tough.
Yeah, so, I don't know, because if I run a mile in like 9 minutes, then, I mean, but that's when I'm out of shape. When I'm really in shape, at like 7 minutes is when I'm like really in shape. And that takes me a mile. And we're going 80 miles. I'm running at about probably 10 miles per hour, if that.
Yeah.
And that's pretty fast for a human being, I think. But, I mean, it's got to take at least like 58 minutes or something.
58 minutes? It's pretty close.
So,
Okay, so I always like that video. It makes me laugh a little bit. But we're gonna take a look at our next set of notes. Okay, on synthetic division. This is a build off of yesterday. All right, and let's just get to it. So first says evaluate f of 2 when you have this entire function. All you're doing is replacing everything with 2. Now we learned a little while ago about this thing called synthetic substitution. When you put 2 out front and you write your leading coefficients down. Okay. So you put your 3, -2, 2, -5, and you bring this down. Here's your 3. Multiply is 6. Atom, multiply, atom, multiply. Okay, and then your answer for f of 2 would be 15, right? Okay. So you could also, if you really wanted to, up top here, just replace all of the x's with 2. Okay. And then you can get your answer this way as well. All right. Sketch this function over here. Y equals the quantity x plus 1 minus 2. I'm assuming they meant squared here. So all they wanted here was a parabola. It's -1, -2 for your vertex. Oops, I'm sorry. It's kind of out of it. So -1, -2, and you build around it. -2, -3, 0, 1. If I plug a 0 in here, 0 plus 1 squared is 1 squared. 1 minus 2 is -1. And then 1 plus 1 is 2. 2 squared is 4 minus 2 is 2. And then you can plot these points. Back 1, down 2. Back 2, down 1. Like so. And then over here would be like this. And there's my parabola. Okay. So, alright. Now, yesterday we talked about polynomial long division, and it wasn't terrible. See if I can focus this in a little bit. It takes some time, but we need a quick and easy way to do these faster. That's basically what it is. So, introducing synthetic division. This can only be used when you divide a polynomial by x minus a variable. You can't have a number in front of your x. It will not work. Okay? So, use synthetic division to find f of x divided by g of x. Here's our problem. I'm going to write this in standard form first. 3x cubed minus 2x squared plus 2x minus 5. Okay, and g of x is this. Now, the whole trick is the following. You take your g of x, what you're dividing by, and you set equal to 0, and you solve for it. So x equals 2. The number that x equals is what you put out front, 2. And then I make my little L. And I'm going to write all the coefficients out. So I write 3, -2, 2, -5. And I'm going to do exactly like I did up here. Bring the 3 straight down. Multiply, 6. Atom, 4. Multiply, 8. Atom, 10. Multiply, 20. Atom, 15. Okay? Now, so we're dividing this, right? Now look what we started with. We started with an x cubed. When you're dividing it, you're lowering it by 1. So what happens is this, it started with x cubed. The first number here becomes your one variable less. So what is x cubed? One exponent less rather is x squared. So our answer is 3x squared plus 4x plus 10. And this last number is always your remainder. So plus 15 divided by x minus 2. Okay, now, hang on for 1 minute while sorry, I had to blow my nose. I didn't think anybody wanted to hear that. Now, probably looking at this going like, what in the world? I want to show you guys something from yesterday. Okay, yesterday's was the exact same problem, and we had to do all this work. But look at what we got here. 3, 4, 10, 15. 3, 4, 10, 15. I know, mind blown, right? So this is a beautiful, beautiful thing, synthetic division. All that work we did yesterday, it cuts it in half. All right? But again, the whole trick is it has to be an x minus or plus something. All right? So let's flip to our back. Sorry, the quotient is what we had for our answer, which is our 3x squared plus 4x plus 10. Then where am I getting that from? The quotient is what's right here, my answer. And the remainder is the last thing, the 15. What do you notice? Well, they work hand in hand together. Okay? So synthetic division gets you the coefficients of your quotient and remainder. It makes it faster. Okay? If a polynomial f of x is divided by x minus k, then a remainder is r equals f of k. Alright? So the remainder theorem is basically, in your own words, okay? You take x minus k set equal to 0, solve for k. So basically you get, solve for x. You get x equals k. And then this is what you synthetically divide by. So the k is what goes out front, and then you divide by everything. What's the remainder theorem allow us to do? It allows us to quickly do polynomial or quickly do division of polynomial functions. Okay, and quickly see if polynomial functions evenly divide into other polynomial functions. Evenly. Okay. So, you know, like I made that little reference yesterday of like, what's 32 divided by 4? And the answer is 8. Well, they went in evenly. Very soon we're going to want to find out if polynomial functions evenly go into other polynomial functions. Well, if that's the case, then our remainder has to be 0. Okay? And this is factor theorem, goes hand in hand with it, and it's huge. A polynomial f of x has a factor x minus k if and only if f of k equals 0. Meaning, if I plug in this value, that makes the 0 there, and I get a remainder of 0, then it evenly goes into it. It's a factor, we call it. Okay? So, here we go. Explain, factor the following if f of negative 3 equals 0. Alright, so, can you guys please notice also, on the previous problem over here, I had x minus 2. This might be the only thing confusing. When you have x minus 2 or something along these lines like a binomial, you need to set it equal to 0 and solve for it. And this problem, they're already telling me what the solution is. The solution is x equals negative 3. It's inside the parentheses. Okay? The only other type you're going to see is down here, x equals 2. I'll show you guys that next. So this negative 3 goes out front. Okay? And I'm going to write all my coefficients out. Well, let me write this in, it's already in standard form. So my coefficients are 2, 11, 18, 9. And all I'm going to do is synthetically divide. Bring the 2 down, multiply. Add them. 11 minus 6 is 5. Multiply. Add them. -9, 0. Yay. Once I get to 0, I win. Okay? Pardon me. Now, what's going on here is I'm dividing this by x plus 3. Now, if you're wondering how I'm getting x plus 3, right here, how do I get it equal to 0? Well, I just add the 3 over. Hence, I get x plus 3 equals 0. So when it says factor, what you have here is you have the x plus 3 out front, and then you have this quadratic, because it was x cubed, and now it drops down to x squared. Okay? And that's it. There you go. It's factored completely. Okay? I don't need the equal 0 in the end, sorry. So, and it looks good. Now it does say factor. We broke it down to a quadratic, all right? And we're good. We factored it all the way. We could check again to see if this trinomial is factorable. It is not, so, oh, it is. Okay. All right. So 2 times 3 is 6. And I want to add 3, or sorry, 5. So it's 2 and 3. So I get x plus 3, 2x and x. Okay. Plus 1 to get 2, and then here's my 3 plus 3. It's factored completely. Okay. That's a 2x plus 3. Alright, cool. Finally, that's factoring. Now, if I want to find the other zeros, I have to factor first, but then I'm going to set them all equal to 0. So here it's much the same. They're telling me x equals 2. If I want the binomial, it's x minus 2 equals 0. But to start off with, I need the 2. Okay. And what I got here, put all my coefficients out. 1, -2, -9, 18. Bring it straight down. Multiply. Add. Multiply. Add. Multiply. So bringing it down one exponent, x cubed turns into x squared. I have 0 x's minus 9. My original one was x minus 2. Okay. I want to find all the other zeros. I can factor this, difference of squares. X plus 3, x minus 3. Set them each equal to 0. Okay. X equals 2. X equals -3. X equals +3. Okay. So it's going to take a little getting used to, but once you get this under your belt, it makes your life way easier than doing polynomial long division. Okay. So as always, keep the good work and good luck. We're all counting on you.